Hello, everyone. Welcome to the Jaxon demo. Today, I'm going to be showing you our policy-based rules. That's a rule set that adheres to a given policy. And I'm going to be showing off one that is adhering to FINRA 2210, which is quite a long policy here. I'll give you a sneak peek. That controls all communications with the public from a financial services company. Things like emails, chat logs, marketing documents, what have you. All right, I'm going to start just by giving a high-level sense. We have something to be reviewed. In this case, it's an email that I'm going to be showing off in our agent today. And it is running up against all the rules that we've extracted from policies, whether they're federal regulations, internal policies, what have you. We have a process to extract rules out of them so we can then enforce them. And then mathematically, we're proving whether or not something does or doesn't satisfy a rule. And then we have a complete audit report so you can see what tripped a rule, what rule was tripped, what have you. And then there's a UI layer where you can see the end result. All right, without further ado, let me show you the Jaxon platform. So there's documentation that we have built out. It's available at docs.jaxon.ai. And that gives a lot of guidance. Of course, we're here to show you the ropes. The benchmarking and the agent is to evaluate the efficacy of the guardrails, the before and after Jaxon. I'm going to dive into this platform now. So clicking over to the screen here, you actually land in applications and you're creating an application that's going to have multiple guardrails. In this case, I'm only going to be showing this one FINRA 2210 guardrail. And what we've done is using LLMs, and in this case, we're using the reasoning model, quote unquote, because you all know that LLMs don't actually reason. They're just emulating reasoning in the form of pattern recognition and looking at a whole bunch of sequences of characters to spit out the right answer on the other side, which is also a prediction. So I'm going to get into that a little bit as I give the demo here, but that's the whole point, is to turn this into a math problem so we can have deterministic, or as close to deterministic outputs as we can get. At least better than human parity as a threshold, in my opinion. Anyway, so we're using LLMs to do the extraction of rules from a given policy. We have the ability to add additional prompting, and on top of the prompt engineering that we already have built in behind this button, which is calling on the utility LLM. So if I go back up here, there are two LLMs being called upon in this agentic workflow. The bigger, beefier model is used as a utility LLM to do the extraction, to turn it into code and do the solving. The lighter weight, faster, more cost-effective model is used for the baseline LLM that's going to be part of the runtime application. All right, so we clicked a button. It used that utility LLM to turn the policy into a bulleted set of rules that reflect the policy, rules that are in natural language still that a human can get into and edit if they so choose. Usually this step is pretty accurate. Doesn't require a lot of heavy lifting to confirm that it reflects the policy properly. Once that's set, you click the button again, calls on that utility LLM again, and it turns that bulleted set of rules into a bunch of our proprietary technologies. It's a language called domain-specific AI language, or what we call DSAIL. So it turns the natural language into DSAIL. DSAIL, you'll see, has a bunch of Booleans, a bunch of assertions. Each one of these are going to need to be satisfied in order for the output to give a full confirmation that something is in compliance in this use case. All right, before we start solving, we need to find answers to pair with these questions to be solved. So the question-answer pair becomes the program that gets run up against these rules to determine whether or not it's in compliance. All right, the questions are still in back-end, natural language, and these are editable. A human can get in here and make changes if it doesn't reflect the policy well. Usually what we're finding is the policy was written by a human for human interpretation. When it gets back to these questions, it's basically what a human analyst would think of in their interpretation of the policy to ask about the data. So that's the question. Importantly, we have this field for additional context per question. So what we find is that a lot of analysts have a lot of knowledge in their head about the given domain, about the given data and use case specific context. And this is where they can add it. They can capture it here. It's able to be used across the organization with other analysts. And importantly, that never leaves the organization. This becomes institutional knowledge insofar as the interpretation of things like regulations, but also for internal policies as well. All right, once all these questions are set, they all, and there's a bunch of them, get wrapped up into a master prompt. The master prompt then goes back to the LLM. This is the mainline LLM now, alongside something to evaluate. So clicking over here, we created an agent to show this off. This is an agent that's calling on the Jaxon guardrails, or in this case, just that one policy rules guardrail around FINRA compliance via an API. And so this agent is one we've created. We can create one custom for you if that's of interest. But if you have teams that are building their own LLM agents, they all can call on Jaxon for this extra rigor around verification. All right, so we have this email that's being evaluated. It's going out and checking every one of those rules. So one by one, this whole chunk of information is checked against each rule. And if there is a representative answer to a question, as I was showing before, that question answer pair gets solved and determined to fail or pass. All right, you can see here that there are a bunch of failures. This is a particularly bad email. But definitely a FINRA no-no to make claims like this. So this gets flagged, and then it goes into the workflow of however the compliance team currently operates. Our big lift here is the ability to use LLMs to do this processing. It reduces a lot of the false positives, false negatives, because the interpretation that the LLMs can make versus the current approaches, the lexicographical searches, the more keyword and key phrase driven approaches that do produce a lot of false positives and false negatives. This is a great way of eliminating those. We are an API layer away to be called upon from your existing compliance applications, or again, any LLM agent that wants to make use of these guardrails. So please reach out if you'd like to have a discussion as to how we can align to your use cases. We'd love to talk to you. You can reach us at info@jaxon.ai. Thank you all.